Hello friends, this is Rashmi Singh. Welcome to my channel Unraveling Science. Let's have a moment of science please. Structure of atom part 2. In this video we are going to learn atomic number or mass number, distribution of electrons in the orbits, what is valency, what are isotopes and isobars, electrovalent bond and covalent bond. We know that atom is divisible into 3 subatomic particles that are electrons, protons and neutrons. Electrons have negative charge and negligible mass. Protons have positive charge and some mass. Neutrons have no charge and mass same as that of protons. Now atomic number. It is the number of protons in the nucleus of an atom. The number of protons defines the identity of the element. The number of protons determines how many electrons are present, as together they make the atom neutral. Thus, the atomic number is equals to number of protons, which is equals to the number of electrons. It is denoted by Z. Mass number. It is the total number of protons and electrons present in the nucleus of an atom. So A is equals to P plus N and it is denoted by A. Symbolic representation of element. X is the element. The superscript A is the mass number and the bottom subscript Z is the atomic number. Distribution of electrons in the orbit. Bohr-Bury scheme. This distribution of electrons in the orbit was suggested by Bohr and Bury. According to this method, the maximum possible number of electrons in a particular shell is determined by the formula 2n square, where n denotes the serial number of the shell. First, or the K shell, where n is 1, has 2 electrons. Second, or L shell, where n is 2, has 8 electrons. The third, or M shell, where n is 3, has 18 electrons, and so on. Shells are filled in a stepwise manner. That means unless the previous or inner shell is fully accommodated, you cannot move to the next shell. The outermost shell of the atom cannot accommodate more than 8 electrons, even if it has the capacity to accommodate more electrons. It is because the elements become stable only after acquiring 8 electrons in the outermost shell. Now let's take some examples. Hydrogen atom has 1 proton and 1 electron and 0 neutron. Helium atom has 2 protons, 2 neutrons and 2 electrons in the outermost shell. Valence electrons. The outermost shell of an atom is called its valence shell, and the electrons present in the valence shell are known as valence electrons. So the carbon atom with the mass number 12 and atomic number 6 has electronic configuration of 2 and 4, 2 in the inner shell and 4 electrons in the outer shell. So it requires to either give 4 electrons, lose its electrons and become stable. So its valency is 4. Now you must be wondering, what is valency? Valency of an element is the combining capacity of that element with other elements and is equals to the number of electrons that take part in the chemical reaction. For example, oxygen, whose atomic number is 8, configuration is 2 and 6, requires 2 electrons to complete its outermost orbit and make it 8. So its valency is 2. Similarly, sodium atom, 11 atomic number, configuration is 281, has 1 extra electron, so it can lose its electron and become stable. So its valency is 1. Potassium atom, atomic number 19, configuration is 2881. Here also 1 extra electron it can lose to become stable, so valency is 1. Chlorine atom, atomic number 17, configuration is 287. It can take 1 electron and become stable, so valency is 1. Similarly, calcium atom, atomic number 20, configuration is 2882, can lose its 2 electrons and become stable, so the valency is 2. So through all these examples, we know that valency is the number of electrons gained or lost by the atom of an element to make its outermost shell complete, that is with 8 electrons. Why do atoms combine? Atoms combine because they have an incomplete valence shell and tend to attain a stable configuration. Elements tend to combine with one another to attain the stable configuration, that is of 8 electrons in the valence shell. This is known as octet rule. However, in case of helium, valence shell has 2 electrons and this is known as duplet rule. As a result of this redistribution of electrons, a force of attraction develops between the atoms which binds them together to form a molecules. This force is called a chemical bond. There are 2 main types of bonds: electrovalent or ionic bond and covalent or molecular bond. Electrovalent bond. An ion is a charged particle which is formed due to the gain or loss of one or more electrons by an atom. A metallic element whose atom readily loses electron or electrons to form a positively charged ion is an electropositive element or cation. You can see a sodium atom loses an electron and becomes sodium ion. A non-metallic element whose atom readily accepts electron or electrons to form a negatively charged ion is called as electronegative element or anion. For example, a chlorine atom gains an electron and becomes an anion Cl-. So we know that a neutral atom when loses electron become cation, and when gains electron become anion. Electrovalent bonds. These are the bonds which are formed as a result of transfer of electrons from an atom of an element to the atom of another element. Bonds formed between metals and non-metals are ionic or electrovalent bonds. For example, sodium gives its extra electron to chlorine and completes its stable state, and chlorine also completes its stable state by accepting one electron. Thus they form sodium chloride. Covalent bond. These are the bond forms between two combining atoms by mutual sharing of one or two pairs of electrons. For example, a water molecule, two hydrogen atoms share their electrons with the oxygen atom and they form a polar covalent bond. There are three types of covalent bonds. Single covalent bonds, where one pair of electrons are shared. Double covalent bond, two pairs of electrons are shared. Triple covalent bonds, where three pairs of electrons are shared. So you can see in the picture the chlorine atom has one pair of electron shares, so one bond. Oxygen atoms, two pair of electron shares, so two bonds. And nitrogen atom, three pairs of electrons are shared, so three bonds or triple bond. So now we can see that ionic bonding is actually like two dogs fighting and one dog steals the bone of another dog. So they form the ionic bond. And covalent bonding is when two dogs fighting and they share the same bone. That is covalent bonding. Among all the elements, only 6 inert gases, also known as noble or rare gases, are non-reactive or inert. These gases do not combine with other atoms to form molecules, since their outermost shell are already complete, so their combining capacity or valency is 0. For example, they are helium, neon, argon, krypton, xenon and radon. Isotopes. They are the atoms of same elements having same atomic number but different mass number. For example, a hydrogen atom has 3 different mass number. One is protium with mass number 1, deuterium mass 2 and tritium mass number 3. Similarly, carbon atom also has 3 isotopes with mass number 12, 13 and 14. These isotopes, they show similar chemical properties as they have same atomic number. Isobars. They are the atoms of different elements with the same mass number but different atomic numbers. Since the properties of elements depend upon their atomic number, they have different physical and chemical properties. For example, atoms of argon, potassium and calcium all have 40 mass number, but their atomic number is different, 18, 19 and 20. Thanks for watching. Please do like, share and subscribe.